Okay, moving on to 14. We want to see what is this guy as a power series. And so this one looks a little scary at first, but again, I see n minus 1, and so I'm kind of thinking it looks like derivative stuff happened here. Let's go ahead and take a look. So I have the old tried and true, 1 over 1 minus x squared is n equals 0 to infinity of x to the n. And I see an n and an n minus 1, so I'm going to check by derivatives. So the derivative of 1 over 1 minus x is minus 1, 1 minus x plus 1 by chain rule. Let me make 100% sure I'm doing that right. 1 minus x to the minus 1. So you're going to get 1 minus x squared down there in the bottom. And on top, you're going to get minus 1 coming down. And by chain rule, minus 1. So yeah, you'll get plus 1. And then d dx of x to the minus 1, 1 minus x to the minus 2. That's going to be minus 2 times minus 1, again by chain rule. 1 minus x is equal to 2 over 1 minus x cubed, because I'll get it to the minus 3. Okay. But why did I just do that? Because the derivative of sum n equals 0 to infinity of x to the n, that's the same thing as if I took a derivative, which is sum n equals 0 to infinity, but not 0 actually, 1. Because I lost a constant term. You want to think of it that way. Also, if I tried to plug in 0, I would get some x to the minus 1 term, but that doesn't make sense because I'm taking derivatives of, at worst, constants, so that should never show up. If I take a second derivative of 1 to infinity of n times x to the n minus 1, I'll get sum n equals 2 to infinity of n times n minus 1 x to the n minus 2. So then this must be equal to this thing I found already. Okay. And that's our final answer. So this should say I need to fix this not as a power series, but as a function. Okay. So that's number 14. Not too bad.